Hello everyone, how are you doing? Welcome to an algebra tutorial video. We're going to be discussing a little bit in this video how to use the right factoring method, how to recognize when to use which method on which polynomial, and just kind of help review a little bit of all the different methods that we've covered so far in this video series. Alright, the first thing you want to do, I don't even have it written here, but when you're given a polynomial and you're trying to factor it down, the first thing you want to do is factor the greatest common factor. You want to get everything out in common, even if it's one term, two terms, three terms, or more. You want to factor all that out of the way, get it off to the side using the reverse distributive property, and then take a look at what you have left. It will make it much easier, it will make it much simpler. And even if you look at something and panic a little bit and you don't know what to start, you can always just find the greatest common factor. It's the very first thing we learned in this video series, and it's where you want to start off with when you're doing a polynomial, trying to factor it down. Okay, but after that, so you've got the greatest common factor out of the way, take a look at what you have left in the parentheses. You need to figure out, is it a binomial? Is it a trinomial? Or does it have four terms? Again, a binomial means there's two terms, a trinomial has three terms, or is it a four-term polynomial? These are all three some of the different cases that we did with factoring. So let's take a look at the binomial. So with the binomial, it's two terms. We looked at the case where you have the difference of two squares. So if you're factoring and you have a binomial, make sure it's two squares and being subtracted. If so, you can factor it into a minus b times a plus b. And again, a and b can be numbers, variables, or combinations of numbers and variables, but that's the pattern that we use when we try and factor it down. You can look at a previous video example if you want to see that broken down a little more clearly. We also have the difference of two cubes. If you recognize you have a binomial and it fits that pattern of something cubed minus something cubed, well then you can factor it into a minus b times a squared plus a times b plus b squared. And the difference of two cubes, we also have the sum of two cubes. A cubed plus b cubed ends up, if you factor it out, into a plus b times a squared minus a times b plus b squared. All right, those are the three examples of binomials that we covered in this series. And give you an idea, they're all special cases, but they all follow this sort of pattern, where if you can recognize the binomial, recognize the pattern that's happening, then you can rewrite it as smaller binomials or trinomials multiplied together. Okay, but what if you have a trinomial? What if you look and you see three terms? Well, again, all trinomials that we talked with fit the pattern of a times x squared plus b times x plus c. And we were really interested in knowing, okay, what is a, what is b, and what is c? Now there's two cases we need to keep in mind. If a equals 1, that was one of the cases, that's actually the easiest form. Then we just need to focus on b and c. We need to find two numbers that add to b, add to equal b, but multiply to c. And once we found those two numbers, boom, we wrote it out, we were factored, we were done. So that's a simple case. If our coefficient in front of the x squared or whatever variable it is, if it's 1, we just need to find our two numbers using b and c, and then rewrite the polynomial in factored form. For all else, however, if your leading coefficient is not 1, Well, then we got some other complicated things we need to do. We still need two numbers. So we're going to find two numbers that add to b. That part's the same. But they also multiply to equal a times c. So we got to use that a coefficient now. So two numbers that add to b but multiply to a times c. Once we have those two numbers, rewrite the trinomial as four terms. And then guess what? Once it's by four terms, we factor by grouping. And there were three examples of doing trinomials with a not equal to 1 where we went through this process. We did factoring by grouping. So you can go back and rewatch some of those. But there we go. So for a trinomial, depending on what a is, we either have an easy method to factor or we have one that's a little bit more complicated in terms of factoring out, and we have to use factoring by grouping. All right. Now if we have a four term, if we find a polynomial with four terms, there's really only one thing we can do. It's attempt to factor by grouping. And those are all the factoring techniques that we've covered in this video series. Factor the greatest common factor first, then look at what you have: binomial, trinomial, four terms. Use the appropriate strategy based on what you're seeing about each of your polynomials. And if you do one method, look at what you have left. You may still need to use another method to factor it completely. We just spent the last three videos in this whole video series looking at involving multiple factoring methods to get it all the way factored completely. But hopefully this helps you kind of put together everything, gives you an overall strategy as you're factoring polynomials and becoming better and more adept at choosing the right method based on whatever polynomial you're given.